Continuing with section 5.3, 5.4. So we saw earlier that if we have a t, real number t, let's say t is over here, and then we go all the way around. So we have t plus 2 pi or 2 pi plus t, however you want to see. So it will have the same value. Sine of t plus 2 pi will have the same value as sine of t has. And similarly, sine of t plus 4 pi, sine of t plus 6 pi, and so on. Even t plus even multiple of pi will give us the same value as just sine of t. And then in the other direction also, we will get the same value. So t minus 2 pi. So this is t minus 2 pi means I am going, starting at t, I am going in the negative direction of on the circle. This is negative 2 pi. So we arrived at the same value with t. So sine of t minus 2 pi will be the same as sine t. And same thing with the t minus 4 pi and so on. So we saw this in the graphs of the sine and cosine. And we can in general say this. Instead of writing them individually, we can in general say that sine of t plus 2n pi is equal to sine of t, where n is 0, plus minus 1, plus minus 2, and so on. And the same is true for the cosine function. So a function which repeats its values regularly over successive intervals of the same length is called periodic, and the length of the interval is called the period of the function. I mentioned this earlier, now you have it in written form. Now we notice that the sine and cosine functions are periodic functions with a period of 2 pi. So this is what you have to remember. So thus we know the period of sine of t and cosine of t is 2 pi. We know that the domain of sine and cosine is negative infinity to infinity, and the range of these functions is negative 1 to 1, including the endpoints. So now we will look at some transformations of these two functions. First, like a little simpler transformation, and then more complicated one. So first, we look at let's sketch the graph of the following functions. Give the domain, range, highest and lowest points. Okay. So the first function I have here is cosine of x plus 3 or 3 plus cosine x. So you know from section 2.6 what transformation is being used here. Shift up 3 units. So what you have to do is graph the cosine function and then shift it up 3 units. So what I did is I have, this is 1, this is 2, and this is 3. And then this will be 4, and so on. Okay. This is my pi over 2. This is pi. And then this will be 3 pi over 2. This will be 2 pi, and so on. So this will be 5 pi over 2. This value will be 3 pi, and so on. So this will be 7 pi over 2. And then we will have 4 pi. Okay. And similarly on this side, this will be negative pi over 2. And this will be negative pi. So in order to shift this up, this dashed function, the red color dashed function is the cosine function. So this one is y is equal to cosine x. That means you write it in the same color so that you can recognize this is y is equal to cosine x. So I have shifted it up 3 units. But like if you recall with the exponential function, which has a horizontal asymptote, so when we shift the exponential function up or down, first thing we do is shift its horizontal asymptote up and down, and then shift the function. Here, this is not an asymptote, so this x-axis over here on which we are taking our, the x values, putting our x values. So that is, you can think of it as the axis of the function sine x. So we have to move that up. So that goes up. So this plot point where you had pi over 2 value, this pi over 2 is over here. So this point has coordinates pi over 2, 3. This will be 3 pi over 2, 3, and so on. This is 5 pi over 2, and so this is how we will draw our graph, move everything up 3 units. So basically what you will do is draw this line, dashed line, put your pi over 2, these numbers on the x-axis, put them on this line here. This is 2 pi. And then you sketch the graph of the cosine like that. Okay. I just did it for you. So and now these, I hope everyone understands these transformations. So now we have, next example is f of x is equal to negative cosine x. So what does that mean? It means the graph of the cosine x has been flipped over the x-axis. Okay, so here is the graph of cosine x. Let's say this is 1, then this will be 2, this is negative 1, it will be negative 2, but we won't need the negative 1, 2 and negative 2. So the graph is flipped over the x-axis. So the point 1 will go to point negative 1. The points on the x-axis will stay where they are. They will not move, but the loose points, we call them, they will shift. So this one, which was a negative 1, will go to 1, and this is going to go to 1. This point is going to go to negative 1. So now the graph will be okay. Okay, so let's see what happens here. So these are two graphs that I'm looking at. One is 2 sine x and the other is 1 half sine x. So what does it do? So this is 1 height, and this is 2. this is -1, this is -2, and you can see this will be like -1/2, and this will be 1/2. So this dashed red one is the y is equal to sine x. The blue one is y is equal to 2 sine x, and this orange is y is equal to half sine x. So notice that how do we obtain these graphs? So the graph of y is equal to 2 sine x is obtained by multiplying the y coordinate of points of sine x by 2. What are the y coordinate points? They will be the values of sine x for the different y values that we x values that we calculate. So each value will be multiplied by 2. So for example, if you recall in the first graph of sine x that we drew, we took the values at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the value at 0 was 0, so 0 will be multiplied by 2, so it will give us 0. At pi over 2, the value was 1, sine sine of pi over 2 is 1, and multiplied by 2, it becomes 2. At pi, it was 0, so multiplied by 2, it was 0. At 3 pi over 2, it was -1, so multiplied by 2, it makes it -2, 0 again. So this is how at pi, 2 pi, 3 pi, 4 pi, and at pi over 2, now the value is 2. So if you notice what has happened, it looks like the graph of sine x has been stretched vertically. So this is what we call the stretching of the graph vertically by a factor of 2. And in the second case, the orange function, which is 1/2 sine x, how do we obtain the value of this one? Well, let me write it over here. So the sine x, sine 1/2 sine x, what will we do? We multiply the value of sine x by 1/2. So it becomes, so when it was 1, it becomes now 1/2. When it's -1, it becomes -1/2. So it feels like it's, by looking at the graphs, it seems like the sine, the graph of sine x has been has shrunk. Okay? There is a shrinking going on in the graph. So we say it is the effect of shrinking by a factor of 1/2. So in general, you will notice that when we have a number in front of the sine function or the cosine function, the absolute of that number, because this number could be negative or positive, so we take the absolute value, which is always going to give us a positive number. So the absolute value of a is called the amplitude of the function, and this is what it does. It either stretches or shrinks the graph. And also it is the largest value that these functions will take, and the smallest value of these functions will be negative of the absolute value of a. And we can see this in this figure example that we just saw. So see, this is the minimum value or the smallest value, which is at -2. So the smallest value is -2, the largest value is 2. And why? Because we're multiplying the function by 2. In the same way, the sine 1/2 times sine x, the largest value is 1/2, the smallest value is -1/2. Now in general, we will have something like this. For you will be given a question like this to graph in the exams. So what what transformations are taking place. So what does this A do? A is shrinking or stretching the function. Yeah? A is, but we say basically we don't mention shrinking and stretching, but but the question asks you give the amplitude. So the amplitude is going to be the absolute value of A. So when you are given this type of equation, or this one, or the sine or cosine curves, the amplitude will be the number or the value which is in front of the sine or the cosine term, or being multiplied by the sine or the cosine term. And you will take the absolute value of that. Always write the absolute value of it, even if it is positive or negative. If in the definition you start by writing absolute A, and then you can say is equal to whatever that number is. Now this B in here, we didn't draw any graph simple by something like sine 2x or cosine 3x or even negative 3x, but basically this number in here, what this does is we call it a horizontal shrinking or horizontal stretching, but this affects the period of the function. Now remember we talked about that the period of the sine and cosine functions is 2 pi. If you have some quantity being multiplied with x, then the period is given by period of the function changes, by the way, and the new period you can find it by this formula, that the period is 2 pi over b. Now the largest value will be equal to d plus absolute value of A, or d plus the amplitude, and the smallest value will be d minus the amplitude. What is this d? Remember, this is a shift up or shift down. If d is positive, it's shift up. If d is negative, it will be shift down. But what that helps here is to figure out what the largest or the highest value and what is the smallest value of the function will be. Now notice that these four things you can actually find them without graphing. Okay? Without graphing the function, you can write all this. Now these two you must write before you start graphing. These two, if you forgot this formula, you can just look up in the graph and figure out what is the highest and what is the lowest value. So let's look at some examples here. So the first one is f of x is equal to negative 3 sine of 2x plus 2. So you can see here A is negative 3, B is 2, and D is also 2. So amplitude, we sometimes just write amp, is equal to absolute value of negative 3, so is equal to 3. Period is equal to 2 pi over 2, so it is just pi. And then highest point, okay, highest value, let's write first, later on we can figure out the points. Highest value or largest value will be, so what is the formula says, d plus the absolute value of A, or the amplitude, d plus the amplitude. So d is 2 and amplitude is 3. The highest value will be 5, and the lowest value or the smallest value will be d minus, so it will be 2 minus 3, which will be negative. Okay, let's see what happens. Now we graph. Now how will we graph this one? This is how you will have to learn to graph these functions. First thing is we'll find out the period, and also we have the highest and the lowest value, so they tell us how much on the vertical axis we have to move. So because the lowest value is going to be -1, so I don't have to leave too much space at the bottom. So I can draw my line over here. Okay. Yeah, I didn't leave enough space here. I think I should have left more space, so bigger graph. So also it says sketch the graph of the function in one period. Okay, so this is how you should do it. So period here is pi. So take a big leap, however big you can go. So for example, over here I will put the period, which is pi. So I'm not going to put 2 pi anywhere because one period is pi, 0 to pi. Half of pi, so always you have to do it like this. Whatever the period is, put that here at the end of your x-axis, half it, then half this side and half this side, this piece. So this will be pi over 4 and this one will be 3 pi over 4. Okay, again, how did I get that? Remember, you can use the midpoint rule, or another way to look at it is, once you got this piece, now this length is pi over 4, so you can count it like this: pi over 4. Now the next one will be 2 pi over 4, which becomes pi over 2. This will be 3 pi over 4, and this will be 4 pi over 4, which is pi. So you can either count or you can use the midpoint formula, which says if you are finding the midpoint of between this and this, so you have pi over 2 plus pi whole divided by 2. This gives me 3 pi over 2 divided by 2, which gives me 3 pi over 4. Okay, so now this is minus, so we are done with working with this. Okay, this is a sine function. Okay, sine is, remember, is 0 at 0. It is 0 at the pi. It will be 0 at pi. Why? Because this is the same as 2 pi in our simple sine x, and it will be 0 here. Well, you might say, but wait a minute, sine of x is sine of pi over 2 is not 0, it's 1. Yes, but we are not talking about sine of, because remember we have sine of 2x now. When you plug in pi over 2 for x, this becomes sine of pi, and that sine of pi is 0. So again, you don't have to worry about evaluating. If you can understand what we do, we take a big leap and write down what a number, which is our period. We have it, and then we have it again, we have it again. So if you recall the sine of x, this is 2 pi and this is pi. This is pi over 2. This is 3 pi over 2. So sine is 0 here at these 3 points. So these 3 points you have to correlate them with the given condition. So in place of 2 pi we have pi, so it will be 0 here. Then in place of pi we have pi over 2, so it will be 0 there. 0, we have 0, so 0 there. Now at this point it will be 1, but since I am multiplying by 3, so I will have to go 3 up and 3 down. Okay, so 3 units up and 3 units down. So let me mark it 1, 2, 3, but I need the 2 more because of this. And also we saw our highest point and lowest point. Highest point goes up to 5, lowest goes up to -1. But let me just put however many I can here. Okay, so -3 sine, so 3 sine 2x. What will this do? So it will give me a value of 3 for here, value of -3 for this one. So this is that piece, 3 times sine of 2x. But we have -3. So -3 means we flip this. So this will become now we have to shift it 2 units up. So every point goes 2 units up. So this was coming down at 3. Okay, and then going up 2 means the lowest point will be at -1. And this point we move to down here at 2. Okay, the line will move, right? This line. So first thing I will do is okay. So now if I erase these, I think it will be better. Okay. So now so at pi over 4. So at 0 it will be 0. At pi over 4 you can plug in sine 2 times pi over 4 means sine of pi over 2, which is 1, and we have -3. So -3 times 1, -1, -3 plus 2, then -1. So at pi over 4 the value will be at -1 here. At pi over 2 it will be 0. At 3 pi over 4 it will be 5. So the graph goes like so. Note here this is going to be 0 over here, -1, -5 over here, So this is the how the graph will look like. Okay, I will stop here, let you guys try to understand how I drew this graph, and then look at the next one in the next video.